Hello everyone. I wanted to explain to you the relationship between the shape of these two curves, total cost and variable cost, and those shapes we have on the lower diagram, ATC, AVC, and MC. So first let's talk about marginal cost curve. Well, we start with TC, which we assume to know. And we also know the shape of VC. Remember, these two curves has exactly the same shape, except that TC is shifted up by the amount of fixed cost, because total cost is fixed cost plus variable cost. And marginal cost, by definition, is the change in total cost over change in quantity. And also it happens to be equal to change in variable cost over change in quantity, exactly for the reason because of the formula I just gave you. So total cost, change in total cost basically is the sum of change in variable cost and change in fixed cost. But because fixed cost never changes with quantity, whatever change in total cost we have comes from change in variable cost. So you can calculate your marginal cost by either using this formula or this formula. And which also means that you can calculate or kind of eyeball your marginal cost as a slope of your total cost curve by drawing like a tangent line to it, or slope of variable cost curve, drawing a tangent line to your variable cost curve. And as I said, they're supposed to be the same, which you can confirm by just comparing these two slopes. They look pretty close. Okay, so now, as we understand it, we can trace the slopes of those curves, drawing those tiny tangent lines and checking their slopes. So what will we see for marginal cost measured as a slope of total cost curve? We'll see that in the beginning, this curve, total cost, is fairly steep, right? But then it starts like leveling out. And that basically reflects in the U-shaped curve of MC and the fact that MC is going down up to this point. As long as this curve is getting flatter, this variable, this curve is going down, which makes sense, right? Because MC again just tells us what the slope is as we measure it on the TC curve, total cost curve. So the flattest part of our TC curve is at this point. And that's where the minimum of our MC curve is. Then the slope of TC curve starts picking up again, and that reflects in the MC curve going upward now, because it just reflects the fact that again the slope of this curve is getting steeper. All right, and yep, we also can tell where the minimum of our MC is, because this is where TC curve is the flattest it can be. Now, after we figured out the shape of our MC curve and its relationship to our total cost curve, and also actually variable cost curve, we could have done the same thing following our VC curve. Now let's talk about ATC curve. So why this curve looks like this, and how does it connect to those two curves? Well, actually, total cost curve above. And to understand the shape of ATC curve, you need to understand how we can eyeball ATC variable. By definition, ATC is just the ratio of TC over Q. Therefore, if you like pick, for example, this quantity, then you can, at this quantity, you can measure TC as this distance, right? Divided by this distance, because this is your Q, right? And this is your total cost. So this ratio also happens to be the slope of this line. Thus, we can pretty much trace our average total cost variable as the slope of those lines that connect the origin of the diagram to whatever point we pick on our total cost curve. So we're going to do the same thing we did with marginal cost curve, which is going to trace the slope of those lines and see how they behave. And as you can see, first they are pretty steep, but they are leveling out, right? Just like marginal cost, but kind of slower. and they're leveling out, which means that ATC is going down, and that actually reflects on the downward sloping section of our ATC curve. And it's going to level down until we hit like our TC curve with this tangent line. You see, like this line that it touches our TC curve will be the flattest possible one describing our ATC variable along total cost curve. And that's why against this point on our TC curve, we're hitting the minimum point on our ATC curve. And after this point, if we keep going further, those lines will be picking up again. So the slope will start getting larger, and that will show on our ATC curve picking up as well. So that's how we can understand the shape of our ATC curve. Another important thing we need to notice here is that MC and ATC intersecting exactly at this point, and it's not a coincidence. In fact, you can see that MC intersects ATC at its minimum. And again, it's not a coincidence because if you think about it, the smallest ATC we got with the line that just touches our total cost curve. And as it touches this curve, it means that it has exactly the same slope that MC, the tangent line that represents marginal cost has. So like the line, like MC by definition at this point is a tangent line, but this one also happens to be tangent line. So that's why MC and ATC are exactly the same at this point, and that is represented by MC intersecting ATC at its minimum, because we also know that the minimum ATC happens to be where our line that goes from 0 to TC curve just touches total cost. Okay, and you can do the same thing when looking at AVC. Again, it just AVC can be interpreted as a slope of a line that connects a point on our VC curve to the origin of the diagram. So this side of this triangle is variable cost, right? And this is, of course, is quantity. So the ratio is basically AVC, but it also happens to be the slope of this line. So we can just do the same thing we did with ATC, tracing the slope of this line, and notice that, it's actually flattening out, right, up to this point. Again, we do that like this. You see, they're getting flatter, getting flattest here, and this is where AVC is getting the smallest, and also this is where MC happens to be equal to AVC. And if we keep going further, these lines will start picking up in terms of slope, and therefore AVC will also start going up. So here it is. This is how things work in terms of relationship between the shape of total cost curve, variable cost curve, and MC, ATC, and AVC.